Hey everyone, and welcome to the AI show. I am Cassie Brevu. I will be your host today, and we have a lot of fun content. So the first part, we're going to be looking at what's new with Form Recognizer, and that will be with Seth and Vinod. We'll take a break for questions, and also ask your questions in the chat during the video. We'll have people there to get all those answered. And then after that, we're going to start with our second video, which I'll be joined by Jessica and Parinita. And we are going to be talking about the ACPT, or the Azure Container for PyTorch. So let's jump right in with our first video. And actually, let me take a look who's hanging out. If you want to say hello in the chat and tell us where you're watching from, that's always fun to see who's hanging out with us today. So I will jump right in.
You're not going to want to miss this episode of the AI show. We're going to talk about the latest from Azure Form Recognizer with my friend Vinod. Make sure you tune in. Hello and welcome to this episode of the AI show. We're talking about the latest from Azure Form Recognizer with our friend Vinod Kurpad. How you doing, my friend? Why don't you introduce yourself?
Hey, thanks, Seth. It's great to be on the show. I'm Vinod Kurpad. I'm a product manager working on Form Recognizer. And really excited to be here today to talk to you about all the new things that we're releasing within Form Recognizer with the new 3.0 GA API.
Fantastic. Okay, so let's just set a level playing field here. For those that don't know about Form Recognizer, can you give us a 30-second elevator pitch?
Definitely. So Form Recognizer has a number of different capabilities. Think about it as starting with OCR. You can extract all the content that you want from any of the document types that you're dealing with. We even support a few different Office type documents, for example, Word and PowerPoint. Those are still preview features, but those are available for you to use within Form Recognizer today. In the GA version of the API, we support PowerPoint as an example. We support PDF documents and or images. And so you can extract text and content from each of those different types of documents that you're dealing with. As you go up the stack of Form Recognizer capabilities, you can extract a number of different semantic elements from the document as well. Things like layout, tables, selection marks, paragraphs, paragraph rows. Those are all sort of capabilities that we have as part of the layout API. If you go further up, you can even use the general document API, which is, think about it as a document agnostic model that extracts key value pairs from a document. You have a number of these common types of forms. For example, you fill out a form at a doctor's office where there's a number of different questions, which is like your name, age, date of birth, past symptoms and things like that. And it's able to process some of these documents without really needing you to build any sort of a custom model, because it can extract all the different key value pairs that you need from each of these different document types that you can use in your automation workflows. And then moving on, we have a few really specific document-specific models, which are things like an invoice model or a receipt model. We even have released now a W-2 model as well as health insurance cards. And so we have a number of these different pre-built model types, which are really targeted at extracting the specific key value pairs that you expect to see in each of these different document types. And finally, if none of these sort of address any of your needs, we have a set of custom capabilities. And we have two different types of custom models that you can use. One is called a template model, which is essentially intended for documents that have a very fixed and defined visual template. And then we have a new neural model now, which is also part of our GA release. And neural models allow you to extract data from unstructured documents as well. So you can extract, for example, tables, layout information, as well as key value pairs from unstructured documents. And so Form Recognizer is intended to serve all of your document automation and document processing needs, starting from simple text extraction all the way to really specific document type sort of scenarios that you might want to deal with.
And this is really cool because it's not, OCR is at the base. It's not just OCR. And then you have structure, and then you have specific structure, and then you have generic structure to whatever it is that you want to do. Am I getting this right?
Yeah, it's perfect, right? Because essentially what we have is I like to describe it as three sets of capabilities, right? So you have OCR, which is essentially extracting text from a document. Then you have these document agnostic models, which are really intended to extract structure as well as key value pairs from a document, but they don't really care whether it's a document whether it's a receipt, an invoice, or a W-2 or a contract, right? So it's all the same from a document agnostic model perspective. And finally, we have these document-specific model types, right? Which are either pre-built document model types, which are essentially a model that Microsoft's trained based on data we've acquired, which are things like the invoice, W-2, and things like that. Or you could go bring your own data, label it, and use a custom model to extract those key value pairs or fields that you're looking for from these documents.
I love it. So what's the latest? So I know there's got to be some kind of announcement that you're making. What's the latest since we've talked last?
Yeah, so I think what I'd like to do is actually walk you through a quick update of what's contained in the new 3.0 generally available API, because this API is now generally available, and it's got a lot of functionality that we've added in, essentially a number of different things that we've done over the past year. So let me share my screen and walk you through what we're talking about here.
Let's do it. Your screen is shared and we're ready to go. Let's take a look.
Perfect. So I'm going to start off by talking primarily about the studio first, right? And the studio is essentially the best experience that you can have with Form Recognizer today. We've taken a lot of the feedback that you had about like the sample labeling tool and things like that in the past, and really revamped the experience of the studio. So the studio allows you to do three specific things, right? First is you can explore each of the different model types, right? So as a simple example, I can go ahead and click on read here. This will open the read API. I can go ahead and click analyze. And now I have a few sample documents here that I can choose from, or I could bring my own document in and upload a specific document that I want to try this out with, and get the outputs from each of these models. So you can see here that in addition to sort of like the sample documents that I've got the output now. And you can see I've got each of these paragraphs identified, and I can take each of the content elements that I want from here. So the studio, for example, is a great way for you to go try out each of these models. So let's go take a look at layout, because layout is another model that got updated as part of our V3 API. And layout, if you remember from prior years, if you've used layout in the past, it usually extracts text, selection marks, as well as tables. With this new update, you'll notice that layout now does something a lot more specific, right? So if you think about all the challenges you have with document segmentation and finer grained detail within a document, you can get those answers to some of the questions that you have about documents you're dealing with. So we tell you what the paragraphs are, but we also give you a specific role for each of these paragraphs. So you can see in this case, the paragraph for the news today is essentially a title type of paragraph. So you're not only getting all of the paragraphs identified, but you're also getting each of the roles associated with those paragraphs. In addition to that, obviously layout also does all the things that it's been doing for the last few years, which is extracting selection marks as well as tables, and we're continuing to improve that experience as well, right? So for example, you can get tables as an example of
That's
things
so
that
cool.
tabular data. It's just get extracted out of the document with no real training required, right? So this is just a layout model doing its thing at this point.
This is amazing. So before you go, basically this is a place where someone can go and just try it out on any kind of document to see what the base stuff does, and it does analysis of unstructured and structured documents. Correct?
Exactly, right.
Cool.
So Seth, you hit the nail on the head. The studio is essentially think of it as a playground, right? So you can go in, select a particular model that you want to try out, analyze a specific document. Like I said, you could use one of the sample documents that are in the studio, or you could go ahead and bring in your own document, analyze it, validate that the results that the model is able to produce meet your expectations, and that's what you'd want to use. And not just that, right? The studio takes it one step further, because it actually shows you what the result is in JSON as well, and gives you a sample example of how you might want to use one of the language-specific SDK elements. In this case, this is a Python sample that walks you through how you might want to use this particular model using the SDK in anything that you're building as an application for yourself.
Love it.
Yeah. So the general document example here that I have on the screen walks you through the capabilities of the general document model, which is essentially extracting key value pairs from each of these different documents, right? So like I mentioned earlier, this is a pre-trained model. You don't need to train anything. It just understands documents and is able to extract all the different key value pairs that it's able to find from within each of these documents. There's a few other examples. You're welcome to go ahead and give it a try. But that's essentially the Form Recognizer Studio in a nutshell. It gives you all of these different capabilities, but it brings out each of these things in a way that's really easy for you to try out, validate that it works, and then take it and productionize it within the applications that you're building.
Awesome. Awesome. And now this is now GA'd, so anyone can use this. Is this correct?
That's correct. So there's two real components that I wanted to talk about, right?
Okay.
The studio itself is how you interact with the Form Recognizer resource or the Form Recognizer APIs. And then there's the underlying APIs itself, right? So obviously the studio is GA, so are the underlying APIs. And so we just talked a little bit about the studio. Let's sort of like dive into each of the different capability areas maybe and spend a couple minutes like walking through some of the updates, because there's a lot to unpack here in terms of like all the different updates that are available within Form Recognizer today.
Let's do it. Let's dive in.
Right. So like we just looked at the general document model. Like think of this as a really good start to analyzing any specific document type, right? So you can bring in any document that has key value pairs or form fields in it. Click analyze, and now you're able to get an output that describes each of the different key value pairs that are extracted as part of this document. So you'll see here that for example, if as I hover over some of these key value pairs, you'll see the proposed start date as well as the specific value and so forth, right? So each of these elements is now extracted for you without you having to do anything more than essentially just submit this document as an API request to the API. So that's key value pairs or general document model. This model continues to improve. It can today extract all the things that layout can, as well as these key value pairs. So for example, you'll see that some of these things like tables that are extracted as part of the layout are also available as part of the output. But in addition to the output from layout, you're getting the key value pairs as well.
That's
you
awesome.
also have selection marks, and so you can see whether each of these selection marks are selected or unselected. And that's something that is just native to the model. It's just able to extract all this information from any of these document types that it's processing.
Cool.
In addition to this, the key area that I wanted to really highlight in terms of what's new with the new 3.0 API is we've now added a new model type called the custom neural model. And custom neural models are different from traditional custom template models that you've trained in the past, because they really enable you to use Form Recognizer with unstructured documents. So as an example, I'll walk you through a quick sort of labeling example of like what we typically do is you need to come into the Form Recognizer Studio, set up a new project, go ahead and label a few documents for what you're trying to extract, right? And the labeling process is super simple. It's intuitive. All you need to do is go select the text that you want and go ahead and label the document, right? So let me show you what that experience looks like. I'm going to zoom in just a little bit so we get a better view of what's going on here. You'll see that I have a few different labels. I can create a new label in here. For example, if I want to create a new field, that might be something like payment terms. I can go ahead and create a new field called payment terms, and you'll see it's probably added to the bottom of the list here. You can also reorder this list and move things around if you wanted to. So I can go ahead and do that, and I'll move payment terms up here. And I don't know if there's any payment terms in this particular document, but let's assume that there was something that I needed to label. It's just a question of essentially highlighting the text that I really want to label, and then selecting the specific field that I want to label it as. And so you'll see that particular term got, the particular field got labeled with the value that I'm looking for. And essentially, it's a question of doing this for as few as 5 documents, and that should then enable you to train a custom neural model. So in this case, it's what I'm dealing with is a few different contracts. And you can see that each of these contracts are different because they're all sort of like with a completely different structure, different style, written by probably different entities, and as a result are significantly different. But I'm still extending this. I'm still using the exact same model to extract the key value pairs that I'm really interested in. In this case, like what are the different parties, and I'm also trying to do some things around clause identification as well to really extract some clauses. So this, with this, I can go ahead and label as few as 5 documents. Go ahead and train a model. And let's go look at what the experience looks like when I have a model trained. I can go and now I'm going to try to analyze a particular document. So I'm going to go find a document here that I can use to analyze. This is a document that I used with the same training data set, but it's not something that the model has ever seen before. So it's not a document that the model is has ever looked at. And when I go ahead and use that document and analyze it, I will get a similar set of results like what we saw when we were using the general document model, for example, right? So you'll see that I can get all the different key value pairs that I was able to identify as part of the label data set. But I also get all of the things that were sort of part of the model from, for example, from layout as well as the read options, right? So it's essentially, think of it as a aggregation of models. So what you're looking at is a combination of the outputs from both read, layout, as well as the custom model that I'm running here.
And this is cool because this is really unstructured data.
Yeah.
That's the coolest part.
This is exactly right. So each of these document types was different. This particular document, for example, that we just analyzed is significantly different from the other documents that we looked at. But what you're seeing here, for example, is the model is able to extract all of the different fields that I was looking for. So, excuse me. So I've got a party that I've labeled that I'm looking for as party 1. I've got the alias for party 1. I've got party 2 that I was looking for as part of the document. I've also got the alias for party 2, the agreement date, and I can also extract clauses, right? So it's not just about extracting specific fields. I can go find the specific clause. So in this case, I'm looking for a force majeure clause, and I see that the force majeure clause is on page 19 of this document. So in each of the samples, force majeure clause may have been on different pages and different sequences within each of those documents, and the model is able to identify what I'm specifically looking for and extract the right values depending on what the specific labels describe, without relying primarily on the structure of the document. So
that's cool. Yeah. I mean, it's basically, now, sorry to interrupt, but an observation, that as Form Recognizer has become more mature, the documents that it's able to process have become increasingly messier, which is really cool.
That is correct, right? And in addition to that, right? So if you think about, like, most organizations, ours is no exception. Unstructured documents is becoming the norm in terms of like how organizations have to deal with this variety of data problem, right? And with Form Recognizer and with the new custom neural models, this is essentially the future of like how we assume customers are going to want to extract all the different key points that they want to extract from each of these different document types that they have to deal with.
This is amazing. So anything else you want to show us, or where can people go to find out more?
Yeah, so I'm glad you asked. There's actually a link at the bottom of the page that you can go look at. That should be the Form Recognizer documentation link that shows you what's new in Form Recognizer today. In addition to that, I just wanted to call out that there's a number of other enhancements or improvements that if you're interested in, please go check it out. For example, I'll talk about things like the pre-built models. We've got a number of new pre-built models as well in terms of things that you can try out. The W2 model is an example of if you've got a tax or a sort of income verification scenario, the W2 model is a great way for you to automate some of those processing. We also have a new model for health insurance cards. So each of these models is essentially intended to help you solve a specific business need dealing with a specific document type. But there's also a wide variety of updates in terms of languages that we support. We're now up to 164 different languages with read and layout. We're in terms of languages that are supported within custom models, as well as languages that are supported with pre-built models. We've now extended to sort of Latin-based languages like German, Dutch, French, Italian, and Spanish. And we've also got a number of other improvements in terms of both the SDKs, APIs, as well as latency improvements. So there's a ton to unpack. There's lots more that I can share, but I know we're running out of time, so I'll stop there and turn back over to you.
I mean, that's cool. Make sure you go to the link. It should be just below. I don't know. It feels like this is the kind of AI that actually helps businesses up-level the kind of work we're doing. Instead of like taking a little form and then typing it into Excel, we can just have the computer do it for us, so we can work on what's really important to our business, which is really cool. Thanks for being with us, my friend.
Oh, thank you, Seth. It's been my pleasure.
All right. So, my friends, you've been learning all about the latest from Azure Form Recognizer with my good friend, Vinod Kurpad. Thank you so much for watching, and hopefully we'll see you next time. Take care.
Wow, that was super cool. I'm going to invite Vinod back on here. There we go. Hey, how's it going?
Hey, Cassie, I'm doing good. How are you?
I'm good. Okay, Form Recognizer. I mean, I don't want to say it's my favorite cognitive service, but it is one of my favorites because it is so useful for so many different tasks. And it just keeps improving. Like those updates are crazy good.
Aren't they? I mean, that's one of the things that we're super excited about, and we've got some really good feedback from a lot of our customers who've tried out the models in preview, and we're excited to see what the rest of our customers are going to build based on Form Recognizer today.
Yeah, and the thing is too is like with Form Recognizer, that affects every type of business. Like it's not just one business that needs different processes happening with forms. It's all over the place, and the addition of unstructured data and structured data, which the structured data you had previously, but there's a lot of new types of models as well. So it's great to see it kind of evolve into this even more useful. So I'm waiting to see if there's any questions in the chat here. So if anybody has questions, now is your time to ask. We are live here with Vinod. If you don't have questions, I have questions. So I will take up this time myself. So one question I had is I noticed when you were making like labeling the unstructured data and you could kind of add that for your custom documents. Can I also do like custom models for my whole document? Like let's say I have different types of documents coming in like document indexing, and I want to know what types of documents they are, and it's custom and specific to my business. Is that also something you can do with Form Recognizer?
Yeah, so essentially we have a capability today we call a composed model, and a composed model, if you think about it, is a collection of models, right? So
Okay.
what we do when you compose a model, let's just say you have three different types of documents. Let's say you have maybe a request for information, you have an application form, and you have you just name it third. I don't know. Let's just pick maybe a bank statement, right? And so now you want to build a custom model for each of these types to extract the values that you need. So you go off and you label a few documents of each of these types with the values that you want, and you create a model for each of those. Now, what you can do is you can actually compose all of these three models together into a single model, and you can call that a composed model. And so let's assume you have a website where a customer of yours uploads a document, right? And you don't know what document they're uploading. They're just saying, here's the document you asked for, right? And they upload a document. Now you can submit that document for analysis to this composed model. And the composed model actually runs a classification step prior to analysis. And it decides which of these three component models is the best suited to analyze this document that you just submitted. And then it routes that particular request to that model. And as a result, it gives you all the outputs from that model, but it also gives you another property, which is called the document type, which basically tells you which of those three component models did I choose to use in terms of analysis here.
That's brilliant. So I train a custom model for each of my type of documents, and then I can create, what was it called? A composite?
A composed model, yeah. So you're just composing these models together into a single model.
Yeah, that's really cool. And I think multi-model solutions are kind of where a lot of things are going, because there's so many tasks you need. And sometimes it's easier to let's focus on one and then put them together in a pipeline that understands what it is, and then, extracts those key value pairs of the information that you need out of that document, and can automate some things that are very manual, I bet, in a lot of companies right now.
Yeah. So we see a lot of like document automation workflows. Obviously, is key to what customers are using it as for. But then there's also scenarios around, like, say, knowledge mining, where you've got all these different types of documents. You're trying to use some of those insights that Form Recognizer can generate to sort of like stratify some of this data. And then finally, you've got like things like maybe some sort of like fraud analytics or something like that, right? Where you're taking a historical view of this data, running through Form Recognizer, and then trying to determine if you can see patterns in the data that might help you with fraud detection, as an example. So there's a wide variety of ways that customers are using Form Recognizer today. But again, it's like you mentioned right at the beginning, it's a problem that every organization has today, like in terms of like dealing with documents as well as dealing with forms and sort of automating processes.
Like, I think the second machine learning model I built was document classification. So I've actually went through the manual process of doing what Form Recognizer does, but like way not as cool and way not as useful. And so just like the amount of time you save by just using some of these pre-built models, it's like, there's no reason to really build your own anymore in some of these situations. particularly because you can also integrate with things like Power Platform. So one of the things I did is I actually rebuilt that, but then I used Power Platform and I used a workflow that actually called into Form Recognizer and then did my classification and then went back to Power Platform and put it in a database. And so now you're talking somebody with no coding skills or machine learning skills can actually leverage this and start automating different pieces. So we do have a question.
Yeah, exactly, right. And I think
Go ahead.
Oh,
Sorry.
yeah, go ahead.
Okay,
No,
so we
I
have
was
a
going to say,
question.
like, let's go to the question.
Okay, so could Form Recognizer differentiate between location information in a document? And then they said, say between a customer location and an employer location where we just want to gather to customer location, and this could be anywhere in the document.
That's a great question. So if you think about it, it all comes down to how you're labeling your document, right? So let's just say you have two locations in a document. One says, this is my customer location, and the other one is describing your say your store location, right? So if you label your document and you say, like, I'm looking for a field that's store location, then it should be able to identify and disambiguate between those two locations to say which of these two locations corresponds to the store location. And then if you have a second field that you could label as customer location, that would or something that sort of helps the model disambiguate between the two sort of locations that you're looking for, the model should pick the right location for each of those particular keys that you're defining.
Because it's so configurable and customizable at this point where it's like you can really customize to whatever your solution is. So
yeah, exactly, right. I mean, so the key with Form Recognizer, though, is to think about it as a sort of I like to use the layer cake analogy, right? So at the very bottom you have OCR, then you have sort of the capabilities that you get from the document agnostic models, things like layout and general document. So we typically run layout as part of most sort of models that you get. And then finally you have the document type specific models, right? And so these are the pre-built models that we know work with a specific type of document. For example, a W2 model knows that it needs to work with a W2 type of document. And then if you have a custom document type that you want to work with, you go train a custom model for that, right? So just sort of like pick the right tool for the purpose, I guess, and try to figure out, like, does layout get you what you want, or does a combination of layout and a pre-built get you what you want, or does a combination of layout and custom get you what you want? So you have to really think through the use case and how you're planning to use Form Recognizer here.
Cool. Yeah, it's always the right tool for the right job. Any other questions people have? Let me see if I wrote down anything else that. Oh, Ignite. I was going to ask you about Ignite. Is there any sessions or things they should look for around Form Recognizer at Ignite coming up?
Oh, we only just released our latest GA update,
okay.
Right this month. So we're sort of on a little bit of a we're looking for feedback. We're trying to hear what customers are saying. We've done a ton of improvements based on feedback within the preview period. We're also continuing to work on sort of our next iteration of what we want to build and how we want to extend these things. So at this time at Ignite, we really don't have a ton of major announcements. We think we're going to probably be more along the build timeframe for major announcements, at least. But we plan to have some of us are going to be at Ignite. I'm not necessarily sure who exactly from our team is going to be there.
Okay.
So please, if you have any questions or want to talk to us, let us know.
That's awesome. Another question I had was about data sources. So you showed in the studio, which is really cool. I can go and I can try and see, okay, what kind of model do I need to use for my solution, and how is this going to react to different documents? Now, when I actually go to use that model, and I'm obviously going to be using like the API and the SDK and stuff that you were showing that I can then use and integrate into my applications. So my question is, what data sources can I connect in? Is it just, would I do that all on the code side once I implement with the API, or is there some sort of tool that you would use within it?
Yeah, we don't necessarily provide a interface into a specific data source.
Okay.
So we have three mechanisms that you can submit a document to us in, right? Obviously API based, but the three mechanisms are, you could just point us to a particular file within a URL, and you can just say, here's the URL to the file that I want to submit. You could send us the file as a base64 encoded payload, and you could say like, here's the payload that contains the file, or you could just stream the file to us, right? So all of those are mechanisms in which you can invoke the API to address a particular location, but we don't necessarily provide a data source per se that says, we understand a specific data source like say storage or SQL or something like that. We don't typically tie ourselves to any implementation as such.
Great. So it's super flexible and you can implement it with whatever data source you're using. You just have to.
Yeah, exactly. Right. So if you're, for example, on storage and you upload a blob, you can always configure a blob trigger to say like, oh, whenever a new blob is added to a storage account within this particular container, invoke this form recognizer request to send this document off to form recognizer, have it processed, take the output, drop it somewhere else, and you got a sort of a process that you can automate.
All right, we have another question. Is there a document type limit per model, or what would be a best practice for a limit?
I'm going to make an assumption here in terms of what the question is, because I'm not exactly clear on what when we're asking about a document type limit. I think there's I'll use the vocabulary that we typically use.
I think I know what it means. I think he means like when I was asking you about different, like classifying different types of documents and then making the model that comes together.
Right.
I think he's asking like, is there a limit of how many classes, how many models I can put in my model that decides what
there
like
is
the
indeed,
classification model?
Yes, there is a limit, and that limit is 200 today, right? So you can compose up to 200 models into a single model.
That's a lot.
That's a lot, right? So yeah. And in terms of like why you might want to do more than that, I think just want to make sure like this comes up a lot in a lot of the customer conversations I have is with a custom template model, for example, you need to create a single model per template variation, right? So for example, you get a bank statement, you get a bank statement from like say bank 1 and bank 2, and they're slightly different in terms of like what things are called, where they're positioned and so forth. Like the header is not in the same place, the line items are not in the same place. You're going to have to create a model for each of these templates and then compose them together to say this is my composed bank statement model. But with the new custom neural models, you don't need to do that. All you need to do is just label a few examples of each of the different variations that you're dealing with, create a single training data set and train a single model, and that should solve your problem. So the sort of guiding sort of principle is when you're dealing with custom neural models, try to as long as all the fields that you're trying to extract are the same from a single document type, treat all the different variations as just a single training data set and train a single model. And that should eliminate the need for you to have as many composed models in the future.
So I suppose you can't have like another layer of I have a classification of a classification and then go in, like, is there?
You can, right? So there's nothing to stop you from composing multiple models together, and each of those could be a composed model in itself. But we still enforce a 200 limit on all of the composed models. So like, for example, you got like 5 models that you compose into compose 1 and another 25 models in compose 2, and you compose those 2 together. We're still going to ensure that the eventual composed model that you build only has 200 component models within it.
But you can have multiple nesting layers of models for making decisions.
Absolutely, you can do that.
Wow, that's super powerful.
Yes, and again, like I said, right, it is super useful in scenarios where customers don't know what their end users are going to be sending them, and they just say, hey, I know it's a document that I need to process, I just don't know which one it is. This is a great way to handle those sorts of problems.
Wow. Well, now is your time to ask any more questions. I don't think I had any more questions for you, but I love to see the progress that's happening there and just see like how powerful and it's becoming, and even more so in ways that are going to really help people modernize their robotic process automation and things like that without having to spend all of the money on building complex models in-house, because that's expensive and time consuming, and we've done all the hard work for you.
It takes a lot of resources to keep those current too, right? So you're going to, the effort is not just in building the model the first time, but the effort is also in maintaining it and keeping it current. So there's a significant amount of challenge there.
All right. Well, thank you so much. Anything else you want to share?
No, it's been my pleasure, Carrie. Thank you, Cassie. It's been fun.
Thank you. Thanks so much. See you.
All right. Thanks, everyone. Bye.
All right, but everybody else, keep hanging out because we're on to our next video. And this is going to be about the Azure PyTorch containers. And we're going to see some neat things that are happening there. So let's jump in. Hey everyone, I'm Cassie Brevu, filling in for Seth today on the AI show, and you are not going to want to miss this episode. We are going to be talking about Azure containers for training with PyTorch and Azure DSVM. Let's take a look. So joining me today is Parinita. Why don't you tell us a little bit about yourself?
Hi, Cassie. Nice to be here. I'm Parinita Rahi. I am a PM in the Azure platform team. So glad to be here to talk about the new container for PyTorch that's now available on Azure.
Cool. Can you tell me a little bit about what this container is?
Sure. So, data scientists, ML engineers, etc. Generally, when they have a training workflow, for large models, one of the challenges that they face is, what are the different dependencies, binaries, etc. I need to get installed to have a ease of setup. This container helps developers, scientists, kind of set up, develop, and accelerate, training workloads meant for large workloads like GPUs for their PyTorch models. It's now available on Azure as a container, as a curated environment, as well as a DSVM. So it's available for like ease of download, and you can get started very easily for any of your training work needs.
That's really cool. So basically, I'm able to create a DSVM or data science virtual machine, or use the container. And now, is the container in part of Azure Machine Learning? Can I use it there as well, right?
Yeah, it's something that you can go to the Azure ML Studio, and in the curated environment section, you can easily go and look it up and get started. So it's a pretty simple workflow that you can now use with Azure ML.
Cool. So you mentioned some of the people that are using this are engineers. So it's like the ML engineers, data scientists. Like, who are the main kind of roles that are going to be leveraging this container?
As I mentioned earlier, it's primarily for data scientists. It's also for like large enterprises who have training workflows on PyTorch. Imagine somebody who has like an NLP modeling workflow for language models, text and speech models, who generally use PyTorch and have dependencies to kind of get that set up. Those are the ideal candidates who will benefit from this container.
What are some of the benefits of using this pre-configured container versus something that they would set up themselves?
So, when you get started, especially with the different versions you have of, let's say, PyTorch or Python or CUDA, and other like essentials that needs to for you to like set up your training workflow, figuring out which version is compatible with what are the dependencies, all of that can take a lot of like back and forth in figuring out like bugs, etc. This container, what it does is it has your essentials required for training. So it has the version of Ubuntu set up with like CUDA or ROCm, depending on which driver you use, with Python versions and the latest PyTorch versions pre-validated and pre-installed. And it's again tested and with a suite of Microsoft internal 1P workloads. So it has been pre-verified. So it basically takes away a lot of the pain that scientists, engineers, etc. have to go through while starting off with their new training scenario. So you just kind of go get it from Azure ML and get started. That's pretty much all you need. And in addition, what it also provides is a bunch of these training optimization libraries. You might be familiar with ORT. which is used for accelerating training of like large transformer models in PyTorch. So you can leverage ORT because it's kind of pre-packaged within this container. You can also leverage deep speed, which is a deep learning optimization library, which makes like training easy and effective. There is also like MSQL, which is a collective communication library that Microsoft open source provides. That's bundled within this container. And these are just a few that I'm naming. That there is a whole lot that you can use. So it's kind of packaged with us looking at these 1P training scenarios and what does it take for a normal workload to be effective, to get started easily, to have optimization, especially since you're running these on GPUs, you would look at training optimization. So all of that is kind of bundled in for ease of setup and acceleration.
Awesome. So I'm going to be able to now train my models faster and set up my training faster, and then maybe leverage this on Azure resources. And then there's that cost savings that comes along because comes along with it as well, because it takes time to set up these containers, right? So there's less time for that. But then also, you're going to train your models faster, so you're going to save money on your cloud computing bill as well, right?
That's true. Like in a lot of like Hugging, I mean, as I mentioned, these are optimized faster training. So your time to compute or time to train goes down significantly. We have seen like 45 to 85% improvements with some of our Hugging Face models. And since, I mean, like you said, it's also helping. It helps you reduce your compute costs as well.
So it has all of these pre-built packages configured together, ready to use. Can I customize it to add some additional packages that might be specific to my model training?
Yeah, so I think Jessica will give a deep dive in a later session, but there are two ways in which you can use these curated environments. You can use them as is, like if you just want to start with something and you don't have other dependencies that you need, which is like already not captured within the workflow, then you can just get started with the curated environment from the Azure ML Studio. However, you can also use this as a base to get started with any additional dependencies you may have. So you can get this environment downloaded and then install any additional dependencies. It definitely minimizes your steps. However, yeah.
Is there anything else you want to share about this container?
Generally, like if you have, like if you're looking for faster training, if your workloads, with the larger models, you want to get started without having to spend a lot of time for setting up, because this is an as-is pre-installed package, and it can also help you scale because you can share within the enterprise. You can easily share it with a lot of your engineers to get started without them having to like worry about these dependencies. And then if you have a workflow on Azure, I think these are definitely like some of the criterias wherein you need to like consider this container. In addition, what it also provides is, because this is on the latest PyTorch version, our teams will continue to provide support and expert troubleshooting and guidance for the latest PyTorch build. So if you're thinking about having any questions addressed as you start off your training journey, or Azure support, all the goodness that comes with it is provided through this container. The other thing is, as I already mentioned, like all of these ML packages that are open source are tested and against a suite of ML workflows within Microsoft. You're basically like leveraging all of the goodness and saving time and saving costs. So all good things here. Yeah.
All right, thank you so much for joining us today, Parinita. Next up, we're going to talk to Jessica, and Jessica is going to show us some demos of this container in action. All right, now we are joined by Jessica, and she is going to tell us a little bit about how Azure Container for PyTorch works. Jessica, why don't you tell us a little bit about yourself?
Hi, and thanks for having me. My name is Jessica Cioffi. I am a product owner on the Azure AI platform, working with the training group. And for this effort, I've been really focusing on connecting the Azure Container for PyTorch and our curated environments that we currently offer on Azure AI.
Awesome. Well, I'm certainly excited to see this in action since we've been talking about it. So let's get your screen shared. Awesome. So why don't you show us how it works?
Sure. So when you enter your workspace in the Azure Machine Learning Studio, you can go down to this Environments option in the menu on the left side, and clicking that will bring you to a view of the different environments that we have. So at the top here, we have both curated environments and custom environments. Curated environments are environments that we have put together. They contain a lot of dependencies and accesses that you guys would want to have when you're running your deep learning training. And we kind of put that all together for you so you don't have to worry about going and trying to find, oh, does this version match with this version of the software that I want to run? We have all that for you, and you are able to use that pretty easily. So initially, when you do come to this view, there is a very long list of all the different options that we have here. We have different versions of different OSs that are there. We have different CUDA versions that you could use as well. So searching for Azure Container for PyTorch, or if you do ACPT for short, you will see our two newest options here. The first one here is for CUDA version 11.3, and the second one would be for CUDA version 11.5. So currently we have those two offerings out for the ACPT curated environments.
Awesome. So these were just added. And so they're brand new for people to try out. And then there was also, like you showed, there's a lot of other environments there that I can use. So I can use these within Azure Machine Learning. Can you show us a little bit about how I might use these?
Yeah, absolutely. So when you want to run a job, you can opt to choose a environment to run that job with. So if we go here to this jobs option, it will bring up a menu where you can run jobs. If you click new here and then go to jobs down at the bottom, you'll be brought up with a create a training job menu where you can go through and select your options. So I will click to do a compute cluster and click my cluster that I have here. Then moving over for the environment type as the second option, you can choose between curated environments, and the options will populate below like we just discussed. Or you can choose a custom environment, which would be something that you'd customize to your specific needs. So for this one, we'll go with our curated environment. And if you expand the option here, you can see all the different information. So since this is our CUDA 11.3 GPU version, you can see that it is version 1 because it is brand new. So I will select this one as our environment. Clicking next, you'll be able to configure your job settings. So you can change the name of your job, your experiment name, and then upload your code accordingly. So I will upload a folder that I have here, and then I will click the folder, upload my code, click upload again, and it will upload the code that I have in that folder. And then to start the job, you have to enter the command. So I will just type in python train.py to make sure that file runs. There are additional options at the bottom for any inputs and outputs you want to add, training applications, environment variables, all these things that you can do to customize your job. I'll click PyTorch here and then click next. And then this last page here in the menu is just where you can review the job specification to make sure that you set everything the way you want. Your compute is set up and what you were expecting, the different settings that you set, so the name, the experiment, things like that, the command that you want to run the training, and the environment you can see here is our new Azure Container for PyTorch, the CUDA 11.3 version. So going with that, I will click Create, and just like that, your job will be started.
Cool. So is there any kind of updates that I need to make to my script that I upload there, or can I take the script that I was using, maybe locally for testing and put it up on this container?
You should be able to. The only thing that would be important to note is that if there are specific libraries that you want to make sure that align with the code that you're running, you could actually use this image that we have as a base image and customize it to make sure that the libraries are included for your specific project.
Cool. So I can take this and use it as like a base environment and then install the additional libraries that I need to customize this curated environment?
Yes, exactly.
Cool. Are we going to see that? Are you going to show us how to do that?
Yeah, let's do it.
Awesome.
So I will bring us back to the environments menu. And like I mentioned earlier, we have the curate environments option at the top, which are all of our preset options. And then I can open up one here and kind of just show a little bit more of the details in the Docker file here. So you can see the properties kind of lined out for you here on the left, and on the right, you can see the base image at the top and then some of the dependencies that we include. So if these are all that you need to run for your project and nothing is missing, you can use it just as is. But if you would like to customize it for yourself, all you would need to do is copy this here, and then you would be able to go to custom environments and click create. So for here, pick a name. I'll just name it my environment. You can add a description if you'd like, or from the select environment type, you can either start from an existing environment if there is something that you already have running in our system, or you can create a new Docker context and use the image. So from the customize menu, you can see some pre-populated information here. So all you would need to do is remove the image that we have here and replace it with the ACPT image. So as you can see, it's the CUDA 11.5 version, PyTorch. And then underneath here, you see we have run pip install AzureML-ML flow. You can change this ML flow to be whatever you need. If you need transformers, you can pip install transformers. And here you can adjust all of the dependencies that you have on top of the base image that we're already providing. So you're able to customize this however you need to best fit your training experiments and experience.
That's awesome. So you can leverage all this work that's been done to create this container that's pre-ready, but then when you just need to add like that little tweak to what you need, it's really easy. You just create a custom environment, import that container, and then add your pip installs.
Yep, and you use it the same exact way when you're setting up a job. So instead of just selecting curate environment, you switch to the custom environment and pick the one that you named. It's that simple.
Super cool. So what are some of the reasons I might use the curated environment or instead of an environment that I was using previously, or the new environment?
Yeah, so this new environment comes with a lot of performance speedups. So by utilizing the best of Microsoft technology for deep learning and distributed training, such as DSpeed, Onyx Runtime, the combination of those options and enabling those when you're using your environment, you can actually see performance speeds from 48 to even double sometimes from your previous runs. So I actually do have an example of an example of this performance increase on some previous runs. So
cool.
Here is, a GP2 run of a NLP training operation. You could see it was completed in 4 hours and 37 minutes using the baseline. If we look at the deep speed by using our curated environment, you can see that the total runtime decreased to 1 hour and 42 minutes. Yeah.
That
so
is amazing.
It went from over 4 hours to a little over 1 hour and a half. That's about a 2.7 times speed increase for the same training job, utilizing our new environment.
That's awesome. So that's time saving, like if you need to retrain things, and money saving on the compute resources.
Oh, absolutely.
Which compute was used for this training?
You know what? Let's double check. So I should be able to go to compute, go to the clusters, and we can see this is an NT24SV3. And I should be able to click here and see some additional information. Yes, so this is a NVIDIA V100.
Wow, that was some impressive performance improvements just by updating to the new curated environment. Is there anything else you want to tell us about the new environment?
Yeah, so the environment is currently in public preview. You can learn more at our Microsoft Azure Machine Learning documentation.
So we'll share that link below here. Go ahead and check out those documentations to learn more. And Ignite is coming up as well. Is there anything exciting happening with these environments at Ignite?
Yes, so we'll actually talking a little bit more about some of the updates and the improvements that the environments have seen at Ignite during our deployment. So definitely check out Ignite to learn some more.
Great. Well, will be setting my calendar to be at Ignite. Well, I'm speaking at Ignite, so I will also know that it's happening. But everyone else should set their calendar and go check out this session so they can learn more about these curated environments. Thanks so much for hanging out with us today, Jessica.
Thanks so much for having me.
All right, so let's now get Jessica and Parinita on stream with us. There you are. Hey.
Hello.
Hi, Cassie.
So that was a lot of information that we just went over, but and super powerful as well. And I got a lot of my questions answered since I was able to interview for that video, and just seeing how much time if you haven't tried to configure all of these libraries together or optimize with different tools and spent all the time trying to figure out, what parameters are best and all of that, that takes a long time to do.
Yeah, I think that's like you hit the nail on the head. I think it's meant for that, like take away all of the headache that scientists, engineers have to go through while setting up their training. I mean, as Jessica showed, it's very simple. It's pretty much click of buttons to get you started. So
yeah, and so like the way that Form Recognizer was, automating the using models from like a UI perspective and not having to customize it. Now we're going into that next level and we're looking at now how can I optimize training and be more efficient and better at that when I am going to have to create those custom in-house models. So what are some of the, like you said, or what's some of the availability for like the SDK and the CLI with this? Like that, it's because it's with Azure Machine Learning, right? That's the SDK that you would use?
Yes, that's correct.
Okay. So is there any updates with that with these new environments or containers, or is that already like a pre-existing feature within the CLI and SDK?
Parinita, do you want to touch on this, or would you like me to?
So I think you could take it, but generally within the AzureML, you have the version of the studio, which is the UI version, and then it's also available as CLI. So you could, you can run through that or through the Python SDK. So all of this is available within the AzureML workflows, like different ways in which you can leverage the container.
So that means that like I can be in my Jupyter notebook and I can be using, creating environments from there too, or I can be using the UI in Azure Machine Learning. And so there's multiple ways that I can actually leverage this and work it into my kind of like development flow, right?
Yes.
Cool. Now, does anybody else have questions out there for them? They are here live to answer your questions about this container. I would love to hear what other people have. I'm not seeing anything yet. Oh, okay, I have another one then. So what type of models and training does this work with?
So we have internally, we've internally tried it on various NLP models, basically speech and text transformer models, as well as a few vision models, and we've seen gains, from 20 to 30 to 40%, depending on different workloads and what setups they used. So it's pretty much meant for larger workloads, ideal for meant for transformer models. And if you have GPU needs for for training, it's meant for those model types. But it's been tested for over 30 to 40 models internally and shown gains across all of those. So and as I had mentioned, even with Hugging Face models, we've tried it with ORT and ORT plus Deep Speed composed together, and we've seen for 8 up to 85% gains with the various settings that folks use. The other thing is this is kind of flexible, right? It works with NVIDIA or AMD GPUs, so it doesn't matter what your underlying stack is. Also, it's composable. Like you can use all of these different acceleration capabilities together. Like you can combine ORT training with deep speed and C gain. So that's another thing that this container kind of provides you with.
Well, I didn't know that it supported multiple hardware, but that makes sense, and that's awesome. And then also, when it comes to large models, that's where you really need that, because those are so expensive to train. So to be able to speed up large models, I feel like that's where you'll see the biggest need for this type of container in the first place. Not to say it won't work on other ones, but I feel like the need to optimize the large models is one of those pain points that a lot of people are feeling when they try to take a GPT-2 or a BERT and then start to fine tune it for their specific task. So we have a question, let's show it here. Can I use ACPT on AML compute instances?
Jessica, do you want to take that?
So thinking right now, I mean, talking about ACPT and the container, the curated environments, I'm not fully sure. Parinita, do you want to add anything for that if it can be used on compute instance?
I need to check that. Maybe
yeah, I'm not entirely sure off the top of my head right now.
I'm pretty sure. No. So like we were using a compute cluster, and I think what they're asking is like, you know, in AML, you have your compute and you can create different types of compute. And the compute clusters are what you use in Azure Machine Learning in order to train your models. So you could definitely use this on a training cluster. Now, if they're asking about the instance where you spin up an instance and you have like a notebook and different things working there, can we use the Azure curated environments within like a compute? So I think a compute instant versus a compute cluster is like what that means, right? That question. Has that been tested at all? Like if I was experimenting?
How about I get back on that, and I don't want to misquote and give a wrong answer.
Yeah.
Yeah.
Okay.
We can probably answer on the YouTube channel.
We will get back to you. Great question. Oh, it looks like this is a form recognizer question. So I will save that for once we are done. Vinod is not still online with us, but we'll come back to that one. Any more questions around the ACPT or Azure container? Not Azure Container Instances. It's Azure Curated Environments. That's what it is with the. All right. Well, thank you so much, both of you, for hanging out with us and showing us this neat feature. I'm excited to get feedback from people trying it out. I hope that they, tweet at us or let us know, reach out if you use these container instances and let us know how they work for you. So thanks so much.
Thank you.
Now, everybody else, you can hang out with us. You can stay on with us. You're not rid of me this quick. Okay, so let me look at this form recognizer question. So when will we prefer form recognizer versus cognitive services? E.g., if I need to text extract, say, a PDF, which has graphics, tables with subgroups and structured data, which option should we choose? So I think what you're asking is there's like all these different services within cognitive services, and you have Form Recognizer is actually one of the cognitive services suite, but we also have a lot of other ones. And at what point do I use which cognitive service? And you can actually use multiple together depending on what you're trying to do. So if you need to first do like maybe Form Recognizer and extract data and key value pairs, and then maybe you put that into a database, and then you do a second one that has, image recognition. I think that would have to be a separate service that we provide in cognitive service. So I think if you have multiple tasks that you need to complete on a particular document or image, then you would need to use multiple services. Now, I know Form Recognizer works on images of documents as well. So I'm not sure if when you're saying graphics, not just images. Let me show this down here too. Does it get the full text in there? Awesome. Yeah, so Form Recognizer works with tables as well, structured. So I think Form Recognizer would do most of this. And when you say graphics, are you saying graphics within a document or a document as an image? That's what I'm not quite sure on that question. But yeah, just like you could use multiple models within Form Recognizer, you might have a second model that runs on a document that does a different task, because when you think about machine learning, you think of it, each model is kind of solving a specific task for you, and then you chain those together to get your automation. All right. Really great questions. Now we are going to, wait, where is it? This one, get to work. All right, so let me get my screen ready here to share. We are going to, so now that we've gone through all of the exciting things that are happening within AI, not all of the things, there's so much going on, but you know what I mean. Let me share my screen here. Great, okay. So the second part here, oh, let me go back to the question here. Let me show this again. For Form Recognizer suits my situation since it fits the, I think, need if it can make sense of images in a document. Okay, so if Form Recognizer can make sense of images in a document, then that would work. And I think it can. But I wish Vinod was still here because we could have asked him that. Also, we got an answer on the compute instances question. Is that currently you would not be able to use it with a compute instance. It's just compute clusters for kicking off training jobs, but it's something that's being worked on. So really great question. And I see Parinita actually added that in the chat as well. So not yet, but it's being worked on. And it's great to see that there's an interest in that as well that helps us understand what people want and need to use. So thanks so much. Okay, let's go back to what we're going to be talking about today. So recently, the Onyx Runtime team released this really interesting blog with NVIDIA, and it was about model optimization. So we're kind of sticking with this theme of optimization today. And this one was showing how to add Onyx Runtime Olive. And if you don't know what that is, that's what we're going to be playing with today, along with the Triton model inference server. Let's see, do I have my zoom in? Oops. I don't have my zoom on. Let me zoom this a little bit. There we go. Hopefully you can see that a little bit better. And then use the Triton inference server to do inferencing. And there's all these different layers of optimization and complexity that you normally have to do and figure out. But with these tools together, you were able to do that. So like when we were talking about the Azure Container for PyTorch, like it's doing a lot of this for you. So if you're training there, but if you want to do it yourself, or maybe you're experimenting locally and trying to figure out how to get your model to work best, there are these tools. So if you go to the repo here, let me scroll this in again. There we go. And I will share this on GitHub as well. So there you go. There is the link. And this repo, oh, we got another question. So this is still back, I think, on the Form Recognizer, and they're asking, how can I recognize multiple PDF page text? Yeah, so if your document has multiple pages, that's not a problem. Form Recognizer can handle that. When you send it off to them, it'll page through. I don't think it has to be a single page, from my understanding. It's another good question. Okay, so Olive, which stands for Onyx Go Live, is a Python package that is going to automate accelerating models. Okay, and so we're going to look at how it does that, and we're going to look at the different features and things that it used, and then we're actually going to try it out too. And just, I haven't really tried this out yet. It was something that I knew of and I had been wanting to try out, so we're going to do it together. So we'll see how this goes. Things might break, naturally. But let's go through and see what this is all about. So it can first convert your model for you. So if you've ever, if you train a model with Python, with PyTorch or TensorFlow, well, yeah, it's usually with Python as well, but you're going to be using something like PyTorch or TensorFlow. So you train your model, and then you need to convert it to an Onyx format in order to leverage the optimization and performance improvements that Onyx Runtime provides and this Olive package. So there's different ways to convert it and different kind of parameters that you can set. And so what Olive does is it actually does it for you. So that's one step. So when you need to then convert your model, that is part of this package. And then the next is, now that I have converted it to Onyx, I can do auto performance tuning with Onyx Runtime. And so there's different optimizations and things that you can apply to your model in order to make it faster, like quantization, threading, parallelism, all these different things that you have to start thinking about, which is, what hardware, what execution providers are you going to be using? And so these different optimization fields and things that you need to manually configure get automated within this. So let's kind of look at what some of these optimization fields are and kind of what they mean. So the first one is execution providers. And I love when they link to things in the document. So thank you, whoever set up this GitHub, where the execution providers is based on what hardware you're using, right? So if you're using NVIDIA GPU, you're probably using, CUDA, TensorRT. If you're using AMD or Intel, so you have all these different execution providers based on, if you're using CPU, GPU, ARM, IoT, all of these different things that have to be considered and have to be optimized in different ways in order to have your model run efficiently on different hardware. So that's one consideration that you need to make when trying to optimize. You have your environment variables and then your session options. So session options is part of the Onyx Runtime when you you can use it as default. So you don't actually have to set these. And if you're not trying to, tune performance, you don't necessarily have to. You can take the default session options, but if you want to configure them to try to get better optimization, you set different ones. You can change them based on the needs of your model and the performance that you're looking for. So some of these different ones are, let me scroll in a bit more here because I feel like that's still a little small. And I can put this link in the docs as well, or in the chat, the docs link in the chat. So thread count. So this controls the number of threads used to run the model. Sequential or parallel execution. So this is, again, one that you can override and set. So controls whether the operator and the graph run sequentially or in parallel. This is something that's going to be auto-tuned for you as well within Olive. Let's see what else we have. Graph optimization level. So there's different optimizations that you can add. And I'm going to send this to you as well. And the different levels. So whenever I use this, I've always just set all. I've never really dived super deep into the different ones that are needed. And with Olive, it'll figure it out for me by auto-tuning these different things. So what it does is it takes all of these different optimization parameters, and it does search. Let's see, where is it? It outputs the option combination. This is the important part. It outputs the option combination with the best performance for latency or for throughput. So all of these different things that you could sit and tweak and tune for your model when you're trying to hit, a certain threshold is going to be automated for you. So you can dive into these as much as you want, or you can use this tool that's going to do it for you, which we're going to play with. And then quantization. So this is going to do int8 quantization, and there's different quantization tools within Onyx Runtime. But essentially what it does, it's going to drastically reduce the size of your model. Sometimes you will lose a little bit of accuracy, but it's going to allow you to get a much smaller, faster model with minimal accuracy loss is kind of the goal of quantization. And to put very simply, it's reducing the size of the numbers. Now, it is much more complex than that, and I'm going to send this to you. And if you want to read about it, you can. But that is another type of performance optimization that you might be doing to get your model to work the way you need, which is part of this. Now it also has transformer model optimization. So what this one does is Onyx Runtime has, optimizations that are going to work for transformer models, but they have an additional package that is specific for optimizations for transformer packages or transformer models. And so this one talks about what you'd have to do in order to use these different additional configurations and optimizations with the Onyx Runtime Transformer optimizers. And you can see how you would do that. But this is all built in to Olive, which I just like that name, but it makes me hungry because I don't know, I'm personally a big fan of olives. I don't know if you all are, but yeah, anyways, food names. But it makes sense when you think about what it is and why they call it that. So we are going to play around with this now that we kind of understand what it is. Is there any questions on that? Like any questions about what it is exactly? Like hopefully that was enough high level information to kind of understand all the different pieces that are coming together within it and why you would use it. So you can go from I've trained my model, and then you can convert and optimize in a much more simplistic workflow is kind of the idea. No questions? Okay, let's play with this then. And let me close out some of these. Otherwise, I'll get lost in tabs. I know some people, they'll just have so many tabs open, and I don't know how they find anything when it's like that. I can't. I have to close things. I guess it kind of helps if you do the vertical tabs. I thought that's what this does. Yeah. So you can go vertical, but no. I'm keeping it old school, horizontal, just closing things. Okay. Oh, and this code here, I'm going to send this to you as well. This is another good resource if you want to play with this. This is from the blog post that was just posted. And this is the source to go through and recreate that and then add in. So we're just going to talk about Olive, but this also has the Triton Inference server and the model analyzer to add additional optimizations. And then the Triton Inference server is like a pre-configured inference server with different optimization libraries. Okay. So let's go back here. So there's some different tutorials here. I'm just going to go with the Jupyter Notebook one. And we're going to just kind of run through these. And these ones I think are separated out. So you can convert. And then this one looks like it's how to optimize latency and one to optimize throughput. So we're going to run each of these notebooks and try them separately. Well, we'll see how many we get through. I don't know if we'll get through all of them, but we'll see how far we get. But you don't have to do that separately. You can do it all together from what I understand about Olive. But since I'm new to Olive and I'm just learning, I like that it's pieced out and kind of lets me try different features. So we're going to go with that. So if I go back here, goodness, this is so small. Let me make this bigger. So now I'm just in my Azure Machine Learning Studio. Let's remove that. That might help a little bit. And I've done a couple things already. One thing I have done is, scrolling, okay, is I have already installed, or I've already downloaded the source. So I've already cloned the Olive repo into my resource. I'm using the compute instances. And I'll just show that quickly. If I go to compute instances, you can see I've created this one and I'm just in the terminal, and then I'm also going to use the notebook. So I'm leveraging the cloud compute here and the pre-configured environments within it. So we will still have to install Olive though. So I've grabbed this. The other thing I've grabbed is this. I've downloaded the wheel that we need to install. We need to pip install into our environment. So if we go, this is the notebook. Why is my dark mode not on? guess actually it's probably easier for you to see in this, so we'll leave it in light mode. But anyways, so this is one of the notebooks for converting with Olive. And so that's what we're going to try first. So the first thing I need to do is pip install this wheel that we just downloaded. And the download is here. I've just already downloaded it into my environment. Make sure I'm in the right spot. Oh, I need to go to notebook. To tutorial. Oh, looks like let me see, can I move? Let's move myself to the side. Actually, that's even worse because then it's super small. Well, can I scroll this? Nope, I can't. Well, I'm just gonna remove myself for a minute. Actually, let's try this one. Is that any better? No, it's not. All right, well, I'll just tell you what I'm doing. So I'm just now in the directory that has the wheel that I need to install. And I'm just going to paste in the pip install wheel. And actually, I just did that without selecting my Conda environment first. So I think that might go globally, but let's see if I can run this. I think I might have to go back and select my Conda environment. So what Conda environment am I using? We'll use the 3.8 PyTorch and TensorFlow. So let's run this and see if my pip install worked. Even I think that does it globally if I don't select the environment. Suspense. Nope. Okay, let's go back and select our environment. So I'm going to list my environments. Oh, I spelled this wrong. That's not going to work. Conda activate. I think we did AzureML, UI, Python, and PyTorch and TensorFlow. Oh, and then I forgot Conda. Again. Okay, now we're in the right environment. Now let's try this install. There might be some conflicts. We were talking about with the Azure container for PyTorch and the conflicts and things. Let's see if that worked. I don't know if it did. Sometimes when there's an issue, it still works, and sometimes it fails. We'll have to try a different environment or maybe create a new one. Oh, nope, that worked. Okay, fantastic. So let's, so this first cell here is downloading our model and example data that we'll need in order to convert. So rather, like if you were using this on a model that you're already working on, you would already have your model and you already have your sample data that you would use. But since we're just kind of running this example, this tutorial provided it for us. And we can confirm that that is downloaded by going back over here and taking a look. Where did it go? Oh, there it is, conversion example. It's right there. Okay, so now we have this model and we have let me turn on my zooming here because this is just small, even with having it scrolled in. I use Zoom It. I don't know if anybody else has used Zoom It, but it's fantastic. And let's see. So now I should be able to. There we go. That is so much better. And then I can draw on things too, which is fun. And I can make like little smiley faces. I could draw a cat as well. the less useful things. But see, this is why you need Zoom It, because then you can do things like draw cats on your picture. Okay. So we now have our sample downloaded. That was so lovely, included in this notebook. So there's different configurations that you need to set, right? Which shows here. So where's the model path? And this has a nice little table that shows you what each one is. So the path to the model, the input schema and output schema. So with Onyx Runtime, when you serialize a model and then you go to use it, you need to know what the input and outputs will be. And so that's what the schema is providing. The opset is the different operation sets. So there's different ones that are supported at different versions. So you want to use the highest one that is supported for your model. You want to give it a name, your sample data, and then which model framework you used. So this is all of the parameters that you need to set in this configuration. And here is what they are for this one. So this is our model path, our input schemas. So this is what it's expecting. And this is the output. Any questions yet? I'm not seeing any in here. Oops. All right, well then I will just keep going. So I think now when I run this, let's see if we're gonna have this without any issues. So now it's running, so it's gonna grab that model. It's going to convert it for me. And they wanna know our feedback about the notebook experience. Should we complete the survey? I super love the notebooks in AzureML, and I like that they're all pre-configured. I also use Jupyter notebooks and Anaconda like locally as well. So it really just depends on what I'm working on. Sometimes I use the notebooks in here. Sometimes I use them in VS Code locally. Oh no, we have our first error. Let's see. We need to install TF2 Onyx. Okay. So let's go back here and install TF2 Onyx. Saying we already have it. Let's try again. Might need to refresh. Oh, it looks like we got further because I don't think it got to this converting step. So while that converts, actually, I want to show you something. So when it comes to convert model to Onyx, kind of show you like why this is easier than what it normally would be. Well, this is with PyTorch. So the thing is like the first thing when you're converting a model to Python or to Onyx is you need to know what framework you trained with. And then based on what framework you trained it with, depends on how you would convert it. And so what this does is it's taking away like, okay, I have to think about how I do it with TF Lite or TensorFlow or PyTorch and all that. And it's just saying, just tell me what framework you used and I will do the rest for you. So there's a good doc that I thought showed kind of all of the different tools for converting to Onyx. See. So we could look at, so this is the TensorFlow one, but there's one that just lists out all of the different conversion tools that I want to show you. And I'm not, of course, I'm not finding it. Here, I think it's this one, Onyx ML tools. Ah, okay, this is what I was thinking of. Now I have my super zoom tool. So these are all of the different things you might use to convert your model to Onyx. Now this one I think is focusing on, TensorFlow and PyTorch, because it looked like those were the options that we could choose from, right? Like, did it give other options? But I thought it just said TensorFlow and PyTorch, which are going to be more where these optimizations are going to be useful anyways for a deep learning model. Where was that? Let's go back here. Okay. Yeah, so currently supported are PyTorch and TensorFlow. I wonder if they're going to keep adding, but that's cool. I know they are working to continue to add features to this. All right, let's go back here. Did it work? Oh, what's our error? Did I need to refresh my kernel? No? Okay, let's see. Conversion failed. Model TensorFlow has no attribute session. So I'm guessing that'd be like ORT session. So TF session. Okay, let's keep going. This was a it was a TensorFlow model. I'm wondering if this is a version issue. I wonder what version of TensorFlow has. Let's search this. I bet I need to install a specific version of TensorFlow. Stack Overflow. What would we do without this? So you must be using TensorFlow 2, which does not use session anymore, but rather greedy execution. Okay, so let's figure out what version of TensorFlow we have and what version we need to install. And you're not really doing machine learning until you run into package version issues, right? Okay, how do I get the TensorFlow version? I think, do I have Copilot on here? I don't think I do. So is it just, we want to import TensorFlow as TF, right? And then, oh, let me see, I want to do TF. Okay, and let's do TF dot, it's usually like underscore ver, right? Isn't that like version? Yeah, okay, let's try that. Okay, so we were using 291. I love the IntelliSense that I get now in my notebooks. When I first started doing this, there was not IntelliSense, and I came from a C# background, and I greatly missed my IntelliSense, so I'm very glad to see that. Okay, but we're on 291. What version do we need to install in order to have session? Was it just 1? Is that what it said? Yeah, I am not sure. Okay, so to get TF1x, like behavior, you need to run. Okay, that disable v2 behavior. I'm going to try this and see if this does what we need. So it says if I import, I probably need to install this. I have never had to do this. This gets the most upvotes, and I feel like Stack Overflow isn't going to lie to me, right? Basic GI is saying don't, and it will ruin it. Okay, well, let's see what else is here. TF2 eager execution by default. This removes the need for session. If you want to run a static graph in a proper way. Oh, so you can still access it using tf.compat v1 session in TF2. Now, I don't know if, can I just run this and then will that update my environment, or does that need to be part of the notebook itself? Let's try it. I don't know. Let's add a code cell. Oops, run that. Okay, let's try this again. Yeah, I think that actually has to be part of the like source. So I think that we need to actually downgrade our TensorFlow. Like that's what I would do. I don't know about this run compatibility mode thing. Okay, let's see here. I think I really just need to install the right package, or let's see. I mean, this gets the most upvotes. Why is this linking to a spreadsheet? Not clicking that. I want to search this. I want to know more about what this is. I think this is what we want. Let's look. This is TensorFlow. So let's look at TensorFlow, see what they say. Okay, bring in all the public TensorFlow interfaces into the map. I'm gonna install this. I think this is what we want to do. It gets the most upvotes. And I think that if we run this and then run our conversion, then I think it'll work. Or at least it'll solve this issue. So do I just pip install? I mean, just gonna make sure is that the install that we want? Is just tensorflow.compat v1, or is it tensorflow.compat? Like, what is my install here? Or should that already be in my, no, because it looked like it didn't. Well, let's try running it. I don't think it recognized it as installed. Let's try it. But I think I have to install it, don't I? Oh, wait, no, I didn't. It didn't have to install it. Okay. Let's try this again now. That didn't solve it, did it? I'm wondering if this needs to, oh no, that's not gonna matter. Try one more, even though it's not gonna work. And then I think we just have to downgrade, which is fine. I wonder if it's the model that's doing. Let's see, where is this actually failing at? The base converter, TensorFlow converter. Let's see. Yeah, no, this is part of the Olive conversion TensorFlow converter. So I think that we'd actually need to put this in. Do I have the source in here? I don't want to compile a new version. Okay, let's. Yeah, I think the best thing we can do is install TensorFlow v1. So I think what we need to do is back up here. If I was in the actual Python file, I think that would work. For some reason, updating this just in my my environment isn't working. Although, did I try refreshing my environment? I didn't. Let's try that. I don't think that will work, but it's worth a try, right? Let's get rid of this and get rid of that. And Oh, oops, I didn't need to rerun that, but it doesn't hurt. And then get Olive, set the compatibility. Really wish it would work just letting me set it in my notebook versus in the script. Conversion example. Oh, did I? Hang on. No, it's not finding this, but it is here. Oh, you know what? I didn't. No, I did run this. Didn't I? Okay, let's run this because we need this conversion example variable. Run here, run the compatibility, and try this again. Okay. Oh, we got so I had to refresh. Interesting. Now let's see, what are we on? What's our next issue? Okay. Oh wait, no, it didn't. It's still failing. Okay. Downgrade we go. Did anybody say downgrade? Or is everyone saying, yeah, this compat, but that we're not going to update the source for this. We are just going to so after 115x, there should be no other 1x. Okay. So I think we can do this. I think this is what we need to do. Or let's look at, yeah, let's look at what the latest version is. Well, the latest of one. Yeah, so 115.5. Let's just pip install this. Let's go back to our environment. Okay, we still have cannot find a version that satisfies the requirement. Why are those all 2? Let's see. So we don't want to upgrade though, we're downgrading. Well, let's try this one. See if that command works better. Nope, so we can't downgrade. Why wouldn't pip have the ability? Oh, thank you, Kevin. So Kevin says it looks like it only runs with Python 3.7, and so we're on a 3.8. So we'd have to redo, I think we'd have to create an all new environment then on a lower version of Python. I don't think I have a 3.7. There's a 3. Well, I think we should just try a new, let's try one of the other optimization ones, because I think we know what our issue is here. But if we only have 15 minutes left, and if I go back and recreate the environment and then run this, I don't think that's as fun as trying out one of the other notebooks. What do you think? Okay. So we have another notebook here. Let's take a look at what the other ones are. Also, I will take this back to the team and have them take a look at it and see. It could be that I'm doing something wrong, or maybe it's the model itself. But it looks, to me, it looks like the file itself in the conversion is actually calling session, like, because it's calling TF session in the TensorFlow Python converter, which is part of Olive, and this isn't available in our version. So it looks like it is something that needs to be updated within the Olive package. So looks like a bug to me. So let's move forward. Let's look at this one. All right, so we will stay in our kernel here. look at something in environments. We're going to come back here in a second, because with the environments, I'm wondering if, like they said, we can't use these in instances, because it's like if I could use PyTorch, Python, like if there was a different pre-configured environment I could just grab quick, that would be super useful. Because like with AML, you have these different environments. You know, these are the pre-configured ones that are set up to use, but there isn't an actual 3.7, so we'd have to create it. I guess we could go through the CLI too. I don't know, I kind of want to fix this. Should we, anybody have an opinion? Should we try the model latency notebook? Or should we set up a 3.7, Python 3.7 environment with TensorFlow 1.15 in order to convert our model? No opinions? Okay, well, we already have this installed. So, oh, it looks like there's some additional installs we need here. So we've done this as part of our prereqs on the first notebook. And then, so install Onyx runtime with pip install extra. This is like a special Onyx runtime for OpenVino. Extra index URL. Okay, well, for CPU or GPU, we are going to be using GPU. So let's install this one. Get that set up, and then I have way too many things open right now to find what I need. Okay, I can close this now, and I can close this. Did I paste this blog in? I'm going to paste this again just because I'm not sure if I pasted it into the chat, but just in case. Okay, successfully installed. Woohoo! And then download the example model. Okay, so now we're going to run this, and we should see our example model show up over here in the optimization example. So this is the TensorFlow BERT for question answering Onyx model. So this is the model. This is a model that's already been converted. It's an open source model that anyone could go use. And I think I need to refresh this. Fantastic. Okay, so now we have optimization example, and it includes this model. Can you see that? So there is our TF for BERT questioning. And so that part's good. So now to optimize, let's look at. So this is going to be, there's going to be a lot more configuration here for optimization. So let's take a look what this includes. Okay, so first, obviously, so the configuration is what we put in our optimization config, all these different parameters that we're sending in, right? So we need to have our model, obviously. So this would be after we had converted it to Onyx, and we'll just pretend like we already did that. But we're using this PyTorch BERT model. Actually, I think it was TensorFlow. And then what is this one? Whether the Onyx runtime package is built with OpenMP. We need our result path. We need, so again, our input spec. So these are the inputs for the BERT question answering. Then our output is our scores. So that would be our result. And that's the name. So that's the name of the output. Oops. I always do this when there's markdown in notebooks. I don't know if other people do this, but I'll double click on something and that actually goes into the markdown cell. Okay. Our providers. So if we want CPU or DNNL. So these are different, all these different optimizations. I don't think we need to go through all of them. Oh, bye, Kevin. Thanks for hanging out. We only have another 10 minutes, so you made it through almost all of it. You got the exciting errors. Got to hang out with us for the errors. Okay. Let's see. So then, oh, there's transformer arguments. Okay, so if we're using a BERT, so I'm guessing that will be included in ours since it's a BERT model, right? Let's see what they have here. So we have our Onyx model. I feel like I should run this because I want to know if it's going to work, and then we'll go back and look. But these are like all of the options that you have. These are not all required. That's another good thing to say. Oh, look at no module. Okay, so we need to install this. Assuming I can just pip install this. I'm not familiar with this. Perf long, yeah. Okay. Although this says CB, this one did not. I wonder if there's a difference. Let's go to the GitHub. Okay, well, this is actually interesting because I didn't know what this is. It's called LoadGen, and it's a reusable module that efficiently and fairly measures the performance of inference systems. So I'm guessing this is probably going to help us understand what things are working better than others. So let's see if I can just do this back to my compute here. I need to do that -cd. Let's see if it works. Yeah, no, okay, so I need this as my pip install, I believe. Oh no, did not find a version that satisfies the requirements from versions none. All right, well, let's see how we install this thing. That's not working. Did I miss a step in the prereqs? Let's just make sure I didn't miss something. Yep, so this is for benchmarking. So that's interesting. Like, that's the thing, is it has all these different packages in there that we'll be using. How do I install you? Is there an issue with this package? This is a relative, no, it's closed. Okay. Let's go back to normally I might have tested all of this out and solved all the issues before we went live. Today, we get to do it together, which I feel like is more fun. Okay, this could be what we want. Let's take a look. Nope, maybe, wait. Let's see. I don't think that's right. Has anyone else used this before? Used this package before? MLPerf LogGen. Now, I thought I found it right away. Can I not? Look at the GitHub. Well, they have some demos. Maybe they include install. This is definitely the right source. Where is your get started? Let's go back again. So here's the overview, which was super helpful. Build instructions maybe, but I thought we could just like pip install. So here's a quick start. We might have to, isn't there a wheel or something? Okay, here's a wheel. Okay, so we need to clone this repo, then go to the wheel location, it appears, run the setup, and then install the wheel. I wish they just made the wheel available somewhere. But I don't think they do. I think we have to do this. I think this is already, okay, well, I'm gonna do some side-by-side here so that I can follow this quick start. So first we're going to install this. All right, now we are going to clone. The repo. Oh, and then I also added the CD. Let's see if that works or if I have to go find it. So I feel like even though there's all these steps, like it's still probably quicker than figuring out the parameters yourself. But we'll see. I don't know that we only have 4 minutes left. So I don't know that we're actually going to get to complete this demo or this experiment, I should say. But we'll see how far we can get. Okay. Still waiting on that clone. And it looks like I should talk a little bit about what's coming up next. So on September 23rd, we'll have the latest from Intelligent Recommendations. I wonder, is that like, I don't even know what that is. What is Intelligent Recommendations? Let's look that up while we're waiting. Sounds really cool. It sounds like probably some sort of a like reinforcement learning type of, let's see, like customizing like an experience, probably through a service. That's really cool. Well, that looks like it'll be interesting. So it calls out to the API based on the data and looks like it makes intelligent recommendations. Well named. Okay, let's go back. Are we cloned yet? Almost. We're almost there. We're almost out of time. Well, even if we don't get to finish out these this Olive Onyx Go Live, it was still pretty cool to kind of like look at it, learn a little bit more about what it does, you know, try it out a little bit. Even if we had issues, like I feel like that's normal. I feel like every time I go and clone something and try to play around with it, there's always different configurations and things that need to happen in order to get things to work. So I feel like that's pretty standard. However, it'd be really cool. So like in the blog, they actually show what they were able to do. And since I hadn't played with this yet, you know, I didn't know all of the different configurations that I would need to do in order to get it to work. But it's been a good learning process. I feel like seeing how it works, what different libraries it's using. It's kind of neat to see this load gen library that I didn't know about for benchmarking, which is probably useful in its own right. Well, I think we're out of time before this is even going to finish cloning. So I think we'll just end here. Thanks everyone for hanging out with me today. I always like filling in for Seth. So we will see you next time on the AI Show.